Hello everyone, welcome to your tutor ZM, and in this video we're going to be looking at the basic application of acceleration and velocity in terms of differentiation in calculus. So let's say we have been given such a question. A point moves in a straight line so that its distance from a fixed point O of that line is, so notice that this is the whole equation for distance, so one that we have right here. This is distance, and then they say after t seconds show that it moves away from O for 3 seconds. So this is basically an equation of distance, and then in respect with time, so they want us to find what happens to the time after 3 seconds. So what we can simply say, because we know that is our distance, we can simply say S is equal to 27t that is n minus t to the power 3. So we have been told that our t is equal to 3. So everywhere we have got t, we're just simply going to replace with 3. So this will be 27, and then let me do this to show that I'm multiplying by t, and then let me get back to that. Yeah, so we end up with a scenario like this one. So now what we can do is just simply simplify. So we have S is equal 27 times 3, that is 81, minus that is 27. So once we subtract, we're going to have S, or displacement, is 54 meters. So that's what we are going to have once we do such a thing. So let's go ahead and try out let's go ahead and try out the second question. So the second question, the distance S meters moved by a point T given by, find the acceleration. So they want us to find the acceleration. So finding the acceleration for at this point is first going to require of us first to find the velocity, or we can simply integrate that. So I think at first what I think I should do is first to find the velocity at that point in time. Let's find the velocity at that point in time first. So to find the velocity at that point in time, what I'm simply going to say is V is equal to ds over dt. So what have we been given as our expression? We have been given t3 minus t raised to the second power plus 4. Yes, right. So we have been given t cubed minus 3t squared plus 4. So let's differentiate this and see what we get as our velocity at a point at the time t. So we can say v is equal, once we differentiate this, we're going to have 3t squared minus 60, and then once you differentiate a constant such as 4, it goes up to 0. So then this is what I get, and then this is all in meters per second. So now that I've obtained my velocity at the point, what I simply have to do is to integrate that to get my acceleration. So now that I've got my velocity, I can simply say 2d Let me do this. And then now that I've got this issue right there, I can say my acceleration is equal to d squared s over d, this is d squared of t. So now that I'm at this point, I can simply write my expression and say 3t squared minus 6t. So now that I've got such an expression, let me just go ahead and clear this. And then now let me integrate this. So then therefore my acceleration will be equal, once we differentiate that, we're going to have 6t, and then once we differentiate negative 60, we're just going to have minus 6. And then remember what our question said. The question said find the acceleration after 3 seconds. So my time is 3. So I'm going to simply say s is equal to that times a certain 3, close brackets, minus a 6. So then therefore my acceleration is going to be equal 6 times 3, that is 18, minus 6. So then therefore my acceleration is 12 meters per second squared, or 12 meters s to the power minus 2. So now I have gotten my final acceleration. Let's go ahead and solve for the last question of the video. Let's go ahead and try. So it says find the velocity v meters per second at in a straight line is given after t seconds by v. Find the acceleration after 2 seconds. So this is going to be very similar from our last question. So they want us to find our acceleration provided that our velocity is given. So we just have to differentiate velocity. So I'm going to say acceleration is equal to dx of d of t, if I'm not mistaken, of d of v, sorry, of d of v. So this is just going to be equal to the expression that we are given for velocity, which is that right there, plus 40. So now let's differentiate this, and so for acceleration, so once we differentiate that, we're going to have 6t plus 4, because this 2 will come to the front and multiply and get a 6, and then to be reduced by power 1. This integrated is basically 4. And then they say that if our t is 2 seconds, so we're simply going to have a, let me just write the standard a, 6, and then our t is 2 plus our 4, so our a, the traditional a, that is going to be 18 plus 4. So our a is going to be equal to, here I've got 18, oh, here we're going to have 12, sorry, 12. This should have been a 12. So this is going to be 12 plus 4. And 12 plus 4 is 16 meters per second. So then this is our answer after we differentiate that. So this is how we basically, so notice that we had this velocity term and then we have managed to convert it into acceleration given a specific time at a point, that one right there. So if you have enjoyed the video, please like, subscribe, share with friends. This has been your tutor ZM. Thank you very, very much. And if you like this new layout better than the old layout, leave a comment and I will be using that one, this one. Thank you very, very much.